Hello, everyone, and welcome to today's Microsoft Reactor livestream. I'm Isabel, your host, and I'm thrilled to have you join us for this exciting session. Now, before we begin, a quick reminder about the Reactor Code of Conduct. We're committed to fostering a welcoming, inclusive, and supportive environment, so please let's keep the chat respectful and constructive throughout the session. I am delighted to introduce our fantastic speakers, Nathan and Patrick. Nathan is a solution architect and Microsoft Business Applications MVP. He specializes in Power Platform and Dynamics 365, using tools like PowerFX and Power Automate to create smart solutions that help businesses tackle challenges. And Patrick is a senior software engineer at Olympic 33 and an Azure Solutions Architect expert based in Auckland, New Zealand. Feel free to drop your questions in the chat throughout today's session, but don't worry if you miss anything in this live stream because the recording will be available on the Reactor YouTube channel afterwards. Now, without further ado, let's give a warm virtual round of applause to our incredible guests.
Hey, everyone.
Good afternoon, good evening, good morning, wherever it is you're coming in from. Let me just quickly share my screen. All right, let's get going. Kia ora, everyone, and welcome to Orchestrating Awesome, your unfair Copilot advantage. Patrick and I are going to take you through a secret to making your copilots and agents so incredibly powerful, it should almost be illegal. So we are incredibly excited to be here to share this with you all today. So let's get into it. Now, before we kick into things, I want to ask you a question. How do we get the music that we love? I don't know if you've ever thought about that before. Not this guy, obviously, but the artists who comprise the soundtrack of our lives. People like the Beatles, or Green Day, Drake, Taylor Swift, Alicia Keys, the Ginger Ninja, Coldplay, or Nirvana. Artists like this, how is their music created? How does it enter our lives? Now, you may be sitting there thinking, Nathan, what a ridiculous question, because the answer is staring us right in the face on the slide here. These are the artists who created the music. They wrote it, they performed it, they recorded it. I saw them live in concert. I have albums with their face on it. I paid hundreds of dollars to see their most recent tour. And you'd be partially right. However, there's another individual involved in creating the music that we love that we need to explore. And in order to do that, we need to take a trip back in time to the 1980s, to a night deemed by the Netflix documentary as being the greatest night in pop. In the 1980s, Lionel Richie organized some of the most iconic, prolific recording artists of the era in a single studio in Los Angeles on one magical night to record a song that became an instant classic. If you're under the age of 30, you may not recognize many of the people in this slide. However, they were some of the biggest artists of the time. And the song they recorded, I guarantee you've heard. We Are the World, We Are the Children. Lionel Richie and these artists wrote and recorded this song to raise funds to relieve famine in Africa. And despite the unbelievable collection of talent in this single studio on this one magical night, every single one of those artists, despite many of them likely having big egos, would have attributed the success of that night and that song to one single person. Do you know who that was? This is Quincy Jones. He was kind of a big deal. He was the producer of We Are the World. He also produced many other iconic songs from recent history. Quincy sadly died last month. However, he's worked with everyone from Aretha Franklin to Stevie Wonder to Michael Jackson, just to name a few of the iconic artists that he's produced. And despite the unbelievable talent of Michael Jackson, Aretha Franklin, Stevie Wonder, every single one of them would have attributed the success of the albums that Jones produced to the fact that he was there producing it for them. Now that's interesting because I've never bought an album with Quincy Jones's picture on the cover. His name may be on the back, but his face has never been on the cover. I've never paid money to see Quincy Jones perform in a concert tour. And yet, he's the man who brings about many of the songs that we love. You see, as a producer, Quincy Jones's job is to make music awesome. He sits at the nexus of the musicians and the artists and the studio engineers and adds everything from those infectious breakbeats to the throbbing bass lines to more cowbell that creates the hits, the final product, songs that we love. And a music producer does this by bringing together the right things at the right time, just the right way to create something incredible. And so I want you to keep this idea in the back of your mind as we're going through our time together today of someone bringing together the right things at the right time in just the right way to create something incredible. Kia ora, everyone. As Isabel said, I'm Nathan Rose, and low code is my love language. I'm a solution architect at Olympic 33 here in beautiful Auckland, New Zealand. I'm also a Microsoft MVP in business applications. As my fellow MVP Mary Myers is fond of saying, how do you know someone's an MVP? Don't worry, we'll tell you. My mission is to unleash human creativity via the Power Platform and low code. And my hope is that by the end of our time today, you'll get just a taste of this mission of unleashing low code. Now, it's going to be a little off brand for me because I'm joined by my colleague Patrick, who is Mr. Pro Code, and we're going to be diving into the world of Pro Code and then bringing it back to low code. Patrick, would you like to introduce yourself?
Hey, absolutely. Thank you so much, Nathan. Hi, everyone. I'm Patrick from sunny New Zealand and quite hot at the moment. I'm one of the senior software engineers at Olympic 33. I've been there for about 4 years now. I've definitely dabbled in Semantic Kernel. Nathan is far too kind with his words. But here's my partner in crime today, and we've created a really, really interesting demo, at least from us. The other things about me that are kind of interesting is I also have a little cat that keeps me company when I work from home, so it's sometimes a little bit hard to come into the office. But yeah, I hope you're excited for our demo today. I've got some really cool stuff to show you.
I can't wait to see it. And Patrick is far too modest to mention this, but he is the first winner of Olympic 33's prestigious Joe McLeod Award. Joe McLeod is the founder of Olympic 33, and Patrick won the award for embodying the values that Joe put into the firm. So you are in good hands with Patrick. Now, a quick overview of our time together today. We're going to start out by exploring what Semantic Kernel is. If you're a pro coder, you might be somewhat familiar with it. If you're a low coder like myself, you've probably never heard about it. So we're going to explore what it is, how it works, so you'll know all about it by the time we're done. We'll then explore how it makes copilots and agents awesome, particularly as it bridges low and pro code and brings it together. We'll talk about why you'd ever want to change LLMs in your AI applications. Then I'm going to hand it over to Patrick, and he's going to show you this amazing demo that he built. You're going to see Semantic Kernel in action across Copilot, the Power Platform, and Dynamics 365 sales. And we'll wrap up with some Q&A. Now, Q&A is my favorite part of these sessions. I absolutely love the questions that you ask. I get my best content and ideas from them, and I just love interacting with you and taking on your questions. So pop your questions in the chat. We love your questions. And for those of you who are fans of 2001: A Space Odyssey, Imagine if they had had semantic kernel. Things might have turned out a little differently. All right, so let's dive into it. What's semantic kernel? Semantic kernel is Microsoft's open source lightweight SDK that's been built for the world of AI. It's easiest to think of it as a type of middleware because it makes large language models and APIs plug and play with the code for your AI applications. This means that you simply select the best LLM for the task at hand. You're not locked into one. It unifies low and pro code. And your copilots and agents are now endlessly extensible, as we're going to show you in just a few minutes. Basically, semantic kernel is the awesome inside your AI applications. So those are the broad strokes. Let's come down a level. Let's get a little more detailed. How is it architected? This is a diagram of semantic kernel architecture that I've cribbed directly out of the Microsoft docs. But let's walk through it. Let's make this let's talk about it. So at the core here, you've got semantic kernel, the SDK. This is what your devs are going to hook up to. At the top here, you've got the code from your AI application. So in our case, we're going to be using an Azure function that's running C#. You can also use Python, Java, other languages as well to connect to semantic kernel. To the left here, we've got plugins. This is basically business logic, things like cloud flows, logic apps, or my personal favorite, PowerFX functions. And to the right, hooks and filters. These are what control the behavior of your business logic, adjusting quantities or filtering product lists and things like that. And then at the bottom, we've got the brains of the operation, the large language model. And this is what we can swap in and out with semantic kernel. So that's the overall architecture of it, but how does it work? Well, again, I've cribbed a diagram directly out of the Microsoft docs, but let's break this down. Let's go into the detail of how semantic kernel actually works. So to start things off, we make a request. A human puts a prompt into a Copilot, into an application, pretty much the same way you do now. We kick things off. Next thing, we invoke semantic kernel. It's going to serialize the functions. Basically what that means is it's going to list out all the things that the developers taught it to do. Out of the box, semantic kernel doesn't have a whole lot of inbuilt functions, but your developers can extend it and write things into it. And Patrick's going to show you that in a bit. So once it gets the prompt, it's going to list everything that it knows how to do. Next, it's time to hand things off to the large language model. And what it's going to do is it's going to pass the entirety of the prompt, so everything that the user has asked in the Copilot, along with all of the functions that the developer has programmed into semantic kernel. So that's all going to get passed to the LLM, and it's going to get processed. And this is where the smart stuff starts happening. So the first thing the LLM is going to do is it's going to determine which functions it needs to run. Let's say we've passed 5 functions to the LLM, and it determines we need functions 1, 3, and 4. The other thing it's going to do is it's going to determine which order those functions need to be run in based on the prompt that it's received. Once it does that, it's time to do stuff. So we start invoking our plugins, our business logic to start doing stuff. And then we rinse and repeat. Send more instructions to semantic kernel to do more stuff. Now, this could either be done by a human, or as we saw at Ignite, as we're entering into this age of agentic AI, you can start to visualize how powerful this could be in the hands of autonomous agents. So just to belabor the point, when a user puts the prompt into an application using semantic kernel, so Patrick's going to be using it, he's going to say, I need you to do something. Semantic kernel is going to list out all those functions, so functions 1 through 5. Next, we're on to the LLM, and we're going to send the prompt, I need you to do something, plus functions 1 through 5. And our final output is going to be, based on the prompt, we need functions 2, 3, and 4. but we need to run function 4, then function 2, and then function 3 to get the result that the user is asking for. So that is how Semantic Kernel works. Let's move on now to laying the foundation for the demo that we're going to take you through. So I'm going to start moving into a world more familiar to me, the world of Power Platform dynamics and low code. This is a terribly drawn architecture diagram of the demo we're going to take you through. So at the center here, you can see that we've got Semantic Kernel and our Azure functions. This is where the C# code is that's interacting with Semantic Kernel. To the left, we've got various large language models that we can hook up to. And to the right, you can see the familiar low-code elements from the Power Platform and Dynamics 365. Copilot Studio, Dataverse, Power Automate, and Dynamics 365 Sales. So let me go through in detail what Patrick's going to show you in just a few minutes. So to start with, a user of Dynamics 365 Sales is going to be working with a custom Copilot in Copilot Studio. They're going to enter their prompt. And when they do that, the prompt is going to trigger a Cloudflow in Power Automate, which is going to interact with Semantic Kernel. So we're going to start working with Semantic Kernel once we've prompted it from our Copilot. And so the first thing it's going to do is it's going to list all the functions Patrick's taught it how to do. And next we're off to the large language model. So the prompt along with the functions are going to be sent to the LLM. In this case, we're using OpenAI. We'll go into more detail on that later. You might be thinking, why are we using the same LLM that powers Copilot? Don't worry, we're going to explain that shortly. So OpenAI is going to determine, based on the prompt, which functions and the order they need to be run in. In the case of this example, the first thing we need to do is talk to Dataverse. And so we're going to go off to Dataverse, we're going to grab a list of products, and we're going to send those back to the user from this Cloudflow and Power Automate that's been waiting for that response. Once we've got the list of products, now we're going to start building a quote in Dynamics. And instead of having to go in and add products individually, we're just going to do that via a prompt. So the user is going to say that they'd like to build a quote. They're going to give a list of products and the quantities. That's going to get Semantic Kernel involved again, and it's going to start executing business logic. Now, in this case, we're going to use Power Automate. I asked for Patrick to build this as low code as humanly possible. You could do this a number of different ways. You could use an Azure function or a logic app or other means of executing the business logic, but we went with Power Automate in order to make this somewhat low code. My goal with this low code meets pro code is for as much as possible to be able to be done by low coders such as myself, freeing up the pro coders like Patrick to build really smart stuff in things like Semantic Kernel. So our Cloudflow is going to take all the products that are in that prompt and the quantities, and it's going to create an opportunity, and then it's going to execute that unbound action in Dataverse that creates the quote. Once it's done that, it's simply going to return a URL to the user in the chat so they can open up that quote in Dynamics 365 Sales. So that's what we're going to show you. All right. In terms of the code behind the scenes, this is a sneak peek at Patrick's code. He's going to go through this with you in a bit more detail, but he's created 3 functions: fetching a list of products, formatting it into a JSON so that we can display it nicely to the user in Copilot, and then passing quantities and products from the final prompt from the user into Power Automate to go ahead and create that quote. So that's the code. Patrick will go through it in a little more detail. All right, but to get back to your burning question, why would we go to all the trouble to use the same LLM, OpenAI, in this demo that powers the Copilot suite of products? Are we kind of going to some redundant effort? Well, when we initially built the demo, we tried to do this with Mistral's LLM. I don't know about you, I'm a little OpenAI'd out. I was keen to see a different LLM in the demo. Unfortunately, Mistral wasn't in a particularly cooperative mood. It struggles with things like chained functions, which are key to the demo that we're going to show you. And in the interest of having a working demo, we swapped out Mistral for OpenAI. Now, this is the part where Semantic Kernel gets really cool. We changed LLMs in our AI application in seconds. You heard that correctly. We didn't have to refactor lots of code. We didn't have to have long nights rewriting the application, tears, aggravation, none of that. We literally swapped LLMs in seconds. All we needed was an endpoint, a model, and an API key. Boom, we were done. It's literally that simple to switch the large language model in your AI applications using Semantic Kernel. All right. But you're probably asking, why would we ever want to switch LLMs in the first place? I mean, OpenAI is kind of the gold standard for these things. Why would we want to do that? Well, when you think about large language models, it can be helpful to think about them in similar terms to the project management diamond. So if we swap project for large language model in this diamond, we've got three main parameters of speed, quality, and cost. Now, there's other parameters that can be used to distinguish between large language models, but these are kind of the most helpful three. All right, so how does this help us in determining which LLM we want to use when building an AI application? Well, in keeping with our theme of the soundtrack of our lives and the music that we love, as my good friend Meatloaf once sang, bring our model back here, we can have a large language model that is good and it's fast. However, it's going to be pricey. So this is the world of your OpenAI. It's literally one of the best LLMs out there. That's why Microsoft selected them to power the Copilot suite of products. It's literally been trained on the entirety of the internet, and it needs to be able to pretty much answer anything you throw at it. Sure, it hallucinates sometimes, but for the most part, it's pretty good and it's pretty fast. But you pay for that kind of quality. In the world of LLMs, like anything else, you get what you pay for. Okay, but why would we ever want anything other than that? Sure, it's pricey, but it's good and it's fast. Well, for your customer-facing applications, this is a no-brainer. Think your mobile app, think your customer portal, things like that. You want to create a great customer experience. You want them to get good information, good answers. You want it to be fast. And so generally, you're going to be willing to pay for that. So for customer-facing applications, this makes perfect sense. What about down here on the left-hand side, though? Let's say we have an LLM that's good and it's inexpensive, but it's kind of slow to process things. It's not as fast as, say, OpenAI. Well, why would we want that? Well, let's say we have an overnight batch process. It's going to run for the next 12 hours while we're all asleep. We don't necessarily need it to be the fastest LLM in the world. We just need to ensure that the quality is good. Well, in a scenario like that, we could actually save a lot of money by using the LLM that's good and cheap. It's just a little slow. Or on the lower right-hand corner, we have an LLM that's fast and it's cheap, but we sacrifice quality. Why would we necessarily want that? Well, at the top of the pyramid, we have our customer-facing applications, but what about our internal applications? Let's say we've got a line of business app that's used in a warehouse or a dispatch center or in customer service. Do we need the best LLM if speed is more important? Well, assuming we can train users to put in a prompt specific enough that the LLM is able to handle it, then perhaps we can sacrifice quality for speed and a lower price, again, saving us some money. So, as my friend Meatloaf once sang, 2 out of 3 ain't bad. And in the world of large language models, that's basically the way you measure them. There's other measures. There's thousands of LLMs out there, and they do differ in subtle ways in terms of how they interpret and display information. but this is kind of a good mental model to use for distinguishing between them and why you might want to swap them out in your AI applications. All right, I think we've heard enough from me. It's time to hand it over to Patrick. Patrick's going to take you through creating a quote in Dynamics 365 Sales with just a prompt with Semantic Kernel. He's then going to take you behind the scenes in the code and the SDK, and he's going to show you how to connect to it. So I'm going to stop sharing my screen, and Patrick, I'm going to hand it over to you, sir.
All right. Thank you so much, Nathan. That was awesome. All right. Let me grab my window. All right. Fantastic. I'm hoping that's coming through. Okay. Hopefully that's on the screen. Can you see that, Nathan?
No.
Apologies. I'll try presenting
had
it
it
one
there.
more time. Oh, sorry. Let's give that one more go.
Yep.
All right, fantastic.
Yep.
All right,
There we go.
great.
Awesome.
All right, awesome. So, hey everyone, Patrick, it's nice to meet you all. And I've never won Lotto, nor have I been able to make a barista grade coffee, but for this demo, I'm going to pretend that I have. So you're going to have to bear with me. So what I'm about to do is show you a toolchain that we've created that can plug into your Copilots here to do some really, really cool stuff that you normally wouldn't be able to do off rip. So I'm going to go ahead and start popping some prompts in like this.
Patrick,
Hi there.
would you mind zooming in a little bit?
No problem. How's that?
Awesome.
Is that a bit better?
Perfect.
Awesome. Thank you so much. All right. So I'm going to say something like, hi there. I'm a very rich barista looking to buy coffee machines.
Things you learn about your colleagues when you do demos with them.
So the LLM responds pretty quick and says something like, what products would you like to know about? Please enter your input. I'm going to go ahead and say something like, I'm looking to make 1 to 5. I'm looking for 1 to 5 coffee machines that can make maybe 100 coffees per hour each. As software
as
engineers,
a nice gift for Nathan because you are so rich.
That would be good, especially if I win Lotto, hey?
Yep.
All right. It's going to think for a second. It's going to call some semantic kernel functions behind the scenes, and it's going to come back, and we're going to see we have a whole bunch of coffee machines that allegedly can make 100 coffees an hour. So I'm looking through these, and I did just win Lotto, but you know, I'm not going to go for maybe the most expensive one, nearly 22,000, but maybe something that's pretty close. Maybe the Cafe Grande with nearly 15,000 each. Jeez, might have to stick to the instant.
Barista, so.
All right, I'm going to go ahead and say I'd like 2 Cafe Grandes. Now, if all goes well, we're going to get some really cool output in just a second for you. All right, so we can see here our flow's kicked off where we're saying 2 Cafe Grandes. And it looks like we've got a response saying, I've generated your quote for 2 Cafe Grandes. And we can go ahead and click this link here to view our quote. So I'm going to go ahead and do that. And if all has gone well, and it looks like it has, we've actually got a quote generated in Dynamics 365 right here for 2 Cafe Grandes.
Amazing.
All right.
Think about a salesperson. This saves so much time for a salesperson putting quotes together. So.
Yeah, the power of pro code and low code coming together, all blended in with some AI.
All right, Patrick. Let's really go for gold. Let's see if we can throw some different products and some different quantities at it, and let's see if it can pick that up.
All right, that sounds great. I'm going to use some mixture of language here. So I'm going to say I'd like a couple more of those grandes. I'd like an AirPod XL and maybe 4 AirPods. Yep. Let's see what happens.
All right.
This to me is probably one of the most powerful things that AI can do, where it interprets the language that we use. Like, we want to use natural language to communicate, but we want to make sure our intent is still coming through.
Oh, absolutely.
Yeah. So if all goes well, we should have about 4 AirPods, an AirPod XL, and a couple grandes.
And a
Let's see
very
how
big
we
credit card bill.
Yes. Thank goodness I've theoretically won the lotto.
Yeah.
All right. Cool. It looks like we've got some response, and that's just come through here. It looks like it's decided to do it 3 different ways for us, so we can go into those and have a look. Fantastic.
It's
So
given us 3 separate quotes.
that's right. Yeah. So again, LLMs can be a little bit unpredictable, wanting to do different things. But it looks like we've got our 2 Cafe Grandes here. We've got our 1 AirPod XL. So if I jump across to that, we should see that here too, which we do. And last but not least, our 4 AirPods. And that
Very
has
cool.
come through.
All
Fantastic.
right, let's try it one more time, and we'll just use normal numbers, and we'll just ask for, like, say 3 AirPods, 2 AirPod XLs, and 5 Cafe Duos, or something like that.
Sure.
And let's see if it
AirPods XLs.
Sticks it all in the same one.
5X Cafe Duos. All right, let's give this a go. Let's see what it thinks.
Crossing our fingers and toes.
Absolutely. Looks like it's separating out based on the intent here. So with the ever-changing landscape that we have through using Copilot, things get interpreted differently. And you can see here, actually, the flow is generated multiple times, where the input is separated out. So I would expect we're probably going to see 3 separate quotes for this again. Yeah.
Yeah, it did. Deepak, I see your question about a combined quote. Patrick, do you mind if I just quickly share my screen? I've got one that I did just
please.
before.
Absolutely.
And I'll just show everybody that it, depending on how we ask the question, we can get everything into a single quote. So let me just quickly present.
Sure thing.
Okay, is that coming through?
Yep, it's coming through.
Fantastic. Okay, cool. So same thing. I've got the list of products. And then what I said was I'd like a quote for 5 Cafe Grande, 3 Cafe PG, 1 and 2 Cafe Duo. And then it's given me my quote. And so you can see that it's done that in the same quote. So it kind of depends on how you prompt it in terms of the result that you get. So LLMs can be a little finicky at times. But Deepak, hopefully that answers your question in terms of being able to get a combined quote. I'll stop sharing. Patrick, I'll turn it back over to you, mate.
All right, no problem. All right, share screen. And we will jump back into here. Well, you've seen it in action, but I figure what might be interesting now is to show you some code behind the scenes, and then I can show you some functions in just a second as well. So as Nathan touched on, we found it really easy to swap our LLMs. I'll just zoom in a little bit to make sure this is nice and easy to see. But effectively, if you're not used to seeing code, basically the front slashes here indicates that this is commented out code, so this won't run, but it is just listed here.
You said that for my benefit, everybody. I'm Mr. Low Code, so.
Oh, look, I'm becoming more and more fond of low code as we work together, Nathan. So that's awesome.
Love it.
He's converted another one. But yeah, basically, all I've had to do is change out the the method that we're calling from add Azure OpenAI chat completion to add Mistral chat completion. We changed the models behind the scenes that we use. And effectively, that's about it. We have prompt execution settings as well. I'm hoping in future this all becomes just one thing, as there isn't really too much difference here. We call auto invoke kernel functions, which basically just tells the AI, you can just call the functions. Don't worry about any extra input from me, the user. Now, going down to what's probably quite interesting is, how how does Semantic Kernel understand what functions it has, and what can it do, and how does it know what to do? So down here, we've got something called the demo plugin for this demo. And effectively, we just have what's called a kernel function decorator here, as well as a description and an action name. So the description and action name are used to kind of give hints to the LLM. This is what you should be using for a particular scenario. You'll also see here the action name is denoted with an underscore here. This is something that seemed like a little footnote in some of the documentation we saw for Semantic Kernel, where a lot of LLMs are typically trained on a lot of Python code, and they find it easier to understand methods that are written like this, as most Python code methods are. So fantastic. From here, we've got some methods like get products from Dynamics 365. I wrote this one before Nathan said, hey, let's make this a bit more pro code. So this one here is actually a connector that I wrote that just gets us products from Dynamics 365, and then we can return them and do whatever we like. This is what you saw when we asked for products. We had a whole list of products that were returned to us. That's how we did it behind the scenes.
Patrick, I've got a question.
Sure.
Any performance differences that you've noticed from executing functions from Semantic Kernel versus, say, calling Power Automate or anything like that? Have you noticed, is it faster, anything like that, to do that directly from the kernel?
That's a great question. I haven't run any like benchmarks per se,
Yep.
but it's been snappy thus far. I think
Yep.
there are multiple ways you could do this. You could even make this faster. Like we're calling the products from Dynamics 365, but because this is in code, you could do such things as like having a database that's on the other side of this,
Yep.
which, you could put on an edge. You could cache those results, making it just super snappy to get exactly what you need. So there are heaps of different ways we could do this, but this one just works.
Yep. Perfect. Yeah. Love it.
All right, cool. And yeah, I thought I'd better shout out the other function that we have here. This is generic and we'll call our Power Automate endpoints. So this is just another thing we wrote that will just say, hey, I'm going to go talk to Power Automate. And with that being said, I'm going to go ahead and take us over to Power Automate. So Nathan's helped me understand this. I come from a really codey background, and I had trouble with putting these flows together, and he's an absolute wizard at it. But basically what we have here is what we're using to call our functions. So if we have a closer look at this, all we're doing is saying for our parameter, we want our intent. This comes from Copilot. So Copilot will pass a message into this flow. And then we have an endpoint here, which is our hosted function that we have in the Azure platform, Azure portal, sorry, where we pass the intent. And then what we'll get is a response. And then we feed that back to Copilot, and that's what then surfaces back in the chat. Now, we do have one more power. Oh, sorry.
Just a quick aside, Patrick, sorry. If you go back to the other flow, so we're using the HTTP connector just because we wanted to be lightweight and get this up and running quickly. If you wanted something that was consumable for your low coders, then you would definitely want to go ahead with something like a custom connector, and then you can make that pro code available to your low coders to just consume in their cloud flows, in their Power Apps, in their Copilots and agents. So yeah, back to you, Patrick.
Okay, thanks, Nathan. Cool. So this is the other flow where I'll be really honest, I struggled with this one, but Nathan's an absolute champ and helped me through it. So effectively from here, what we're doing is we have an HTTP trigger that we can then call from our app, which will then basically pass some information about products, the customer, etc. Everything that we need to make an opportunity in Dynamics 365. From there, we loop through all the products that we have from there and then create an opportunity off that. And then from there, we generate a quote off that opportunity, and we take the unique ID of that opportunity, of that quote rather, and return that as part of our flow. Copilot can then pick that up and create a link that you saw, which eventually we can then click on the other side for the user. Hopefully I've explained that right, Nathan.
Absolutely.
All
Absolutely.
right. Fantastic. Cool. Yeah, that's it from me. I might pass it back to you, Nathan.
Awesome. Cool. All right, let's get back into our slide deck. All right, is that coming through?
Yes, it is.
Fantastic. Okay, so Patrick has taken you through creating a quote in D365 Sales with nothing more than a prompt. This is something, again, usually takes salespeople a lot of time having to put together, and we just did it with a few keystrokes in a prompt using Copilot Studio and Semantic Kernel. He's taken you through the SDK and how to connect to it. So thank you, Patrick. That is an amazing demo. Blows me away every time I see it. And yeah, it's absolutely love it. And of course, this is how things might have gone if we weren't using Semantic Kernel. All right. So as we wrap things up, you might be asking, why wasn't the demo more ambitious? I mean, yeah, okay, we saved some salespeople a bit of time creating their quote, but why didn't we tackle some of the big questions, right? Why didn't we tackle demand forecasting or sales planning or customer service resourcing or something like that? Great question. In AI projects, there's kind of two ways of thinking about them. You've got your grandiose ones, right? That's where we try to solve sales forecasting, demand planning, customer service forecasting. Or you've got what our CEO, Martin Wildsmith, likes to call thin slices. And what you just saw is a classic example of what Martin would deem a thin slice. How do we distinguish between the two? Well, your grandiose AI projects tend to be high cost and high risk, right? If we try to solve demand planning for an organization, we can't just go build an AI application to do that. First, we need to get a team of BAs in there to understand all of the business processes. We need to get a bunch of solution architects in there to model all the data and how it flows around the organization. Once we've done that, we need to put together a bunch of user stories and requirements. And by the time we start building, there's a very good chance that in fast moving spaces like AI, particularly with copilots and agents, that it's moved on before we've ever delivered version 1 of this grandiose project to try and solve the big, huge problem that we thought we could solve with AI. So this means that it's really hard to realize value, and these projects tend to end in tears. If we ever realize it at all, it's going to be on an old version. It's going to be on yesterday's tech, but more likely than not, this is doomed to failure. It's going to end in tears. All right. How do we get around all of that? Well, this is where thin slices comes in, like the demo that you just saw. Thin slices projects are low cost and low risk. The demo that you saw, Patrick put together in a matter of days. It didn't take reams of user stories and requirements and BAs and solution architects coming up with solution documentation. We literally had a thought bubble and we went away and we built it. And so with these thin slices projects, we can deliver in weeks at the most, not months or years. So we can start delivering value rapidly. You want to be thinking in terms of minimum viable productivity. Where's a gap in our organization? What's something that takes us a lot of time that we could quickly develop something in AI to fill that gap? And what starts to happen is this has a flywheel effect, and we have this impact where the whole is greater than the sum of the parts, because we've got all of these thin slices generating value, generating efficiency and productivity across the organization. And that's the way to win with AI. And you might think, well, Nathan, that sounds a little strange, but believe it or not, that's how the Power Platform got to where it is today. The Power Platform, sure, there's some big stuff that's built in it, but in the Power Platform, a lot of what was built in the old days and what's built today are those thin slices, those point-to-point minimum viable productivity solutions. We need a Cloudflow to automate this thing. We need an app for this small little piece of our business process. And as a result, the Power Platform is scaled. And in the same vein, this is how you scale AI in your organization. Attack those thin slices, and I guarantee you're going to win. All right, so this brings us to the end of our time together. Thank you all so much for coming along. Thank you for your time and your attention. We've covered off Semantic Kernel. We've learned all about it, what it is, how it's architected, how it works. You've seen how it acts like a producer, like a music producer for your copilots and your agents. It brings together the right things at the right time and in just the right way to create something awesome. In this case, a sales quote from a prompt. You've seen how it bridges the low and pro code divide, how low coders like myself can consume AI applications created by pro coders like Patrick, and how we can work in concert to create amazing experiences for our customers, for our organizations, for the customers of our organizations. And lastly, we've explored why you might want to use different LLMs in your AI applications depending on the context. If it's customer facing, then it needs to be fast and good and expensive. If it's an overnight batch process, it might need to be good, but you can get away with slow and cheap. Or for a line of business application, you could sacrifice quality for speed and low cost. So thank you all so much for your time and for your attention, and we're happy to open it up to questions.
Thank you guys for the fantastic presentation. It looks like it was so good that we don't have any questions in the chat.
Wow.
But,
okay.
Yeah, I know. You guys killed it.
Oh, thank you. Yeah. If anybody does have any questions, anything you saw that you think about later, this is how you get in touch with Patrick and myself. We're on all the things. Yeah, we'd love to chat more about it. So yeah, do reach out with any questions that you have.
Absolutely. Always happy to answer some questions on Semantic Kernel. It's a really exciting space to be in.
Yeah, absolutely.
Great. And thank you to our viewers for joining us today. Like I mentioned at the beginning of the session, if you missed any part of this live stream, the recording will be available on the Reactor YouTube channel right after we end the live stream. If we don't have any questions, I think we might end the live stream now. But like Nathan said, and their info is also in the chat, feel free to reach out to these guys. They're rock stars and they will be more than happy to help you. But I wish everyone has a wonderful rest of your day. And thank you, Dimitri, for joining us from France. This is fantastic.
It must be early there. Wow. You won,
really early.
the award, Dimitri. Thank you. Yeah.
Thank you, Dimitri. And thank you all for joining us. And hope you have a great rest of your day. See you guys.
Thanks, everyone. Bye.
See ya.